Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into designing TikTok, the short-form video platform that serves a personalized, infinite feed to billions of users. We'll cover how TikTok, Instagram Reels, and YouTube Shorts handle video uploads, real-time transcoding, content delivery networks, recommendation systems, feed generation, and ad insertion at massive scale. Whether you're preparing for a senior engineering interview or building video infrastructure, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we are doing a complete deep dive into designing TikTok, the short-form video platform that serves a personalized, infinite feed to billions of users worldwide. If you have ever wondered how TikTok, Instagram Reels, or YouTube Shorts handle video uploads, real-time transcoding, content delivery networks, recommendation systems, feed generation, and ad insertion at massive scale, this video is for you. We will walk through the functional requirements, non-functional requirements, high-level system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FAANG interview or building video infrastructure, let's get into it. Here is the core problem. TikTok has hundreds of millions of daily active users who upload, watch, and interact with short videos constantly. Every time a user opens the app, they expect an endless, highly personalized feed that starts playing instantly, with no buffering, and keeps them engaged for minutes or hours. Meanwhile, creators upload raw videos from every device and network condition imaginable. Those videos must be transcoded into multiple resolutions and formats, stored cheaply, distributed globally, moderated for safety, indexed for search, and scored by a recommendation model within seconds. On top of that, the platform must insert ads natively without hurting the user experience, handle viral spikes, and operate across regions with very different privacy laws. The challenge is building a system that is fast, cheap, scalable, and addictive all at once. Let's walk through the functional requirements. First, users must be able to upload short videos, add captions, music, hashtags, and effects, and publish them to followers. Second, the platform must transcode every uploaded video into multiple resolutions and bit rates, generate thumbnails, and store the variants durably in object storage. Third, the system must generate a personalized for you feed by retrieving candidates, ranking them with a machine learning model, applying diversification and freshness rules, and paginating the result. Fourth, the platform must support social interactions such as likes, comments, shares, follows, and direct messages, and must propagate these engagement signals back to the recommendation model. Fifth, it must support discovery through search, trending pages, and sound pages, plus monetization through in-feed ads, branded content, and creator analytics. These 5 capabilities form the backbone of any short-form video platform. Now the non-functional requirements. The feed must be extremely low latency. The first video should start within a few hundred milliseconds of opening the app, and scrolling to the next video should feel instant. The upload pipeline can be more asynchronous, but the publish experience must still feel responsive. The system must be highly available because users open the app habitually throughout the day. Even brief downtime causes massive engagement loss. It must scale horizontally to handle billions of videos, tens of millions of uploads per day, and millions of concurrent viewers. Global distribution matters because latency from a user in Southeast Asia to a data center in Virginia is unacceptable. Cost efficiency is critical because video storage and bandwidth dominate the bill. Data consistency can be relaxed for some features, like view counts, but must be strong for user state, like follows and privacy settings. And privacy compliance is non-negotiable across regions. Here is the high-level system architecture. On the left, mobile and web clients connect through a global CDN and load balancer to an API gateway. Upload requests go to the upload service, which stores raw video in object storage and publishes a job to a message queue. Transcoding workers consume the queue, produce multiple video variants and thumbnails, update the video metadata service, and push the final files to a CDN for distribution. The recommendation service runs candidate generation and ranking models, reading from user profiles, engagement history, and video features. The feed service assembles the final ranked list for each user. The ads service selects sponsored content to insert naturally into the feed. Social interactions are handled by an engagement service that writes to databases, caches, and event streams. Analytics and monitoring pipelines feed data back into the recommendation and business intelligence systems. The key metrics to memorize cold. Feed latency, the time from opening the app to the first video playing, should be under 200 milliseconds. Watch time per user per day, the total minutes consumed, is the core engagement metric. Daily and monthly active users measure growth and retention. Upload success rate tracks the fraction of uploads that publish correctly, including retries. Cache hit ratio on the CDN and edge caches directly impacts cost and latency. Recommendation click-through rate and watch-through rate tell you whether the ranking model is working. Video transcoding latency measures how quickly a new video becomes available. Ad fill rate and revenue per mil impressions measure monetization health. These metrics are what the business actually cares about. Let's trace the end-to-end user journey. A creator records a 15-second video on her phone, adds a trending sound, and taps upload. The app gets a pre-signed URL, uploads the raw file to object storage, and the backend enqueues a transcoding job. Within seconds, multiple resolutions are generated, a thumbnail is extracted, and the video is replicated to edge caches. Meanwhile, the recommendation engine indexes the video and prepares to show it to relevant users. A viewer opens the app, and the feed service immediately returns a ranked list of videos tailored to her interests. As she scrolls, likes, and shares, every interaction is streamed back to update her profile and the recommendation model in near real time. The creator later sees view counts, likes, comments, and audience analytics in the creator dashboard. The core models and algorithms. The video metadata model stores the video ID, owner, caption, hashtags, sound, variants, thumbnails, privacy flags, and moderation status. The user profile model captures demographics, interests, device, location, and watch history. The engagement graph records likes, comments, shares, follows, and watch time, and is used both as a feature store and as a signal for viral distribution. The recommendation pipeline usually follows a two-stage or two-tower architecture. Candidate generation retrieves hundreds or thousands of relevant videos quickly, and a ranking model scores them by predicted watch time, likes, and other engagement signals. Content moderation runs pre-publish and post-publish filters, combining rule-based checks, machine learning classifiers, and human review queues. Feed generation applies ranking, diversification, freshness, and business rules before returning the final list. The key trade-off is relevance versus diversity. A perfectly personalized feed can trap the user in a bubble, while too much diversity hurts engagement. Now the low-level design deep dive. The upload flow is asynchronous. The client requests a pre-signed URL from the upload service, then uploads the raw file directly to object storage. A successful upload triggers an event on a message queue. Transcoding workers pull the event, decode the video, generate multiple resolutions and bit rates, create thumbnails and previews, and write the variants back to object storage. Metadata is stored in a relational or wide-column database, while the CDN is warmed with the most popular variants. The feed flow is read-heavy. The client requests the feed service fetches the user profile, calls the recommendation service for candidates, applies a lightweight ranking and diversification layer, and returns a paginated list. To keep latency low, the next few videos are pre-computed and cached at the edge. Social rights like likes and follows are recorded in a distributed database and asynchronously replicated to caches and analytics pipelines. For high traffic, everything is sharded by user ID or video ID. Key takeaways for your interview. First, the recommendation system is the product, so spend time on candidate generation, ranking signals, and the trade-off between relevance and diversity. Second, the upload pipeline is fundamentally asynchronous. Separate ingestion, transcoding, and distribution, and use object storage plus message queues to absorb spikes. Third, feed latency is critical for user experience, so lean heavily on CDN edge caching, precomputed feeds, and pagination. Fourth, the CDN and caching strategy are as important as the database design because video bandwidth dominates the cost and latency profile. Fifth, monetization and ads must be designed into the feed from the start, not bolted on later, with clear separation between organic and sponsored content. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for Design TikTok. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on Designing TikTok. We covered the full picture, from upload pipelines and transcoding, through recommendation systems, feed generation, CDN strategy, and low-level design trade-offs. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.